Welcome everybody. Thanks for coming to this session. This session's about logical data warehouse. My name is Mike. I'm an independent industry analyst based here in the UK, although I work pretty well all over Europe and around the world. So I want to talk to you about a number of things this morning. The first is the fact that there's a real thirst for new data, and we saw that yesterday when I revealed the results of the fourth industrial revolution survey here in the UK, and what the impact of that new data is on organizations trying to be able to look at it, analyze it, and maximize the value out of it. Also looking at why the classic data warehouse architecture is no longer going to be enough to be able to handle this, and what logical data warehouse will do for you in order to be able to maximize the value that potentially comes from all of this new data, and how to implement logical data warehouse using data virtualization. And then look at how you can transition, if you like, from where you are now, perhaps to that kind of an architecture, and try and keep the access to the data simplified in order to enable value to be delivered pretty quickly. So for most of us, this architecture pattern is best part of 25 years old now. It's classic data warehouse, integrating data from transactional systems into a centralized data warehousing environment with some dependent data marts on it, typically on an analytical relational database, and we got some kind of BI tools sitting in front of that with either web access or desktop access, and in many cases now mobile access to BI all available. But for most organizations today, transactional data and transactional activity is no longer enough. If I take a look at any business, it has a front office, marketing, sales, and service. It's got a back office, so procurement, HR, finance, and some kind of product or service lines that you're creating to sell into the marketplace. And of course, suppliers at one end and customers at the other. But all kinds of new data now pouring into the enterprise. For example, to understand more about your operations, we've got sensor data coming in many cases, to get a much deeper insight of what's going on in everyday business operations. Customers, all kinds of external data that customers, things like what they're saying about your product or your brand from an opinion perspective, understanding additional data that on your website, for example, online behavior and whatnot, all pouring into the enterprise to try and understand more about customers. And of course, external data could be open data from the government websites that are out there, could be weather data, which is a huge impact on sales from almost every vertical industry, and also things. We've now got connected things either on your wrist, could be the cars that you drive, appliances that you buy even from your own household. So when you look at this, there's a huge amount of new data that isn't in a data warehouse that is coming into an enterprise that businesses now want to analyze. Machine data like clickstream for online behavior, like various kinds of log files, everything from even IVR system, when people call in, even understanding that kind of activity, application server logs, database logs, all of that. Connected things, as I mentioned, semi-structured data, a lot of this is JSON based these days. Still some XML out there, but a lot of JSON. We've got unstructured text coming in the form of tweets, for example. Could be other kinds of documents, even if you download, say, SEC filings to understand more about companies, you'll get all of that coming down in document format that you have to be able to do natural language processing on to get data out of it. And so all of this data is not the kind of data you would see in a classic data warehousing system. And why is it that we want it? Well, if I just take a look at the front office, the customer, for example, on the right-hand side, we've seen how we used to interact. Customers used to interact. They would contact an employee either face-to-face, such as a branch of a bank, a store. Well, that still goes on, of course, but we would have contact to the contact center or call center, and they would interact with an employee, and the employee would use a user interface to talk to an application or a computer system. But today, it's the left-hand side of this chart which is really driving most businesses. It's the digital channels. And over there, interaction changes. There is no employee that a customer interacts with. They interact with an application. and therefore the application is going to have to get smart in order to understand the customer if the only way a customer is going to interact with your organization is digitally through an app and not through a person. and clearly this is what's causing a lot of attention. We saw yesterday in the survey, #1 use case in the UK for data and analytics is now customer. Everything to do with a customer to improve customer engagement, because these people are now dealing with applications. There's very little time to engage with them. Not only that, they're far more informed. There's comparison websites, and they can churn on a single click, just a touch of a phone. They can churn and go somewhere else. And so it means that loyalty is now cheap. And so big investment to try and understand much more about a customer going forward. So it's not just transactional activity that I want to know about anymore. I need customer master data. That's probably one of the hottest areas in BI that I'm seeing right now, customer master data. Also, I want behavioral data, whether it's online behavior. I want to know their location. I want to know about opinion on social networks. All of it is needed, and I need it integrated in order to be able to get a much more complete picture of customer activities. Similarly, with sensor data, I need to be able to bring in a lot more data to understand what's going on in my business operations, whether it's supply chain or distribution chain optimization. Could be manufacturing production lines. We could be monitoring the grid, whether it's water, electricity, all of that, smart metering, all of that sensor-based. A huge amount of data not typically found in a classic data warehousing system. And of course, things. Now, if all of that's pouring into the enterprise, it's a deluge. And so the explosion of data sources means that people are challenged with how to cope with that and ingest that and understand that data quickly and be able to turn it into some kind of value. And when you look at this kind of data, with it, some of it being semi-structured, some of it's huge volume and structured, some of it is unstructured, the question really is, is that going to go in a data warehouse or not? And a lot of people are saying, really? How are we going to be able to deal with that within a classic data warehouse architecture? So if I take a look at that classic architecture that we've had for 25 plus years, and you look at something like streaming data. So what would you do with streaming data with this architecture? Bearing in mind you want to react to it quickly and understand what's going on, like clickstream, online behavior. Would you put that in a staging area? I mean, how long would it be before this data comes in for a user up here to react? If data goes into a staging area, then we've got to get it out of there into some production data warehouse tables, get it out of there into data marts, and then give it to a user. What this tells me is with this kind of live streaming data, which is clearly on the growing rapidly now within many organizations, is that this architecture is just not going to work because there's just too many data stores between the arrival of the data and the time the user gets to see some value out of it. It's not responsive enough. It's not agile enough. So a 25-year-old architecture isn't going to handle it. What we want to be able to do is bring this data in. We want to be able to integrate it with other historical data that we might have in a data warehouse and maybe master data. But we want to do that in flight. We want to be able to analyze it in flight before it's stored anywhere, and we want to be able to act on it in flight before it's stored anywhere, and either push alerts or whatever to devices, to dashboards, so that we can see real time on the same dashboard as historical data. And we might want to filter that data, or some of it, for further offline analysis into a big data platform like Hadoop, because the volume of streaming data like clickstream coming in is so large that we would need a scalable platform like that to do that. So that doesn't fit with a classic architecture, but we really want that data. Similarly, we'll say, oh, give everybody self-service and we'll just have them access it. So every time I see a new release of a BI tool, I just keep seeing more data connectors, more data connectors, more data connectors. So what's the answer? Do we just give it all to the user and say, here you are, all of these thousands or hundreds of data sources, you figure it out? I mean, how is that agile? Do we just say, you figure it out and force the integration complexity on the user to be able to do this? In reality, I think that's not what self-service BI is about. Self-service BI should be about taking complexity away to allow organizations to be far more productive with the data, but take complexity away so that they can deliver value more rapidly. So just giving them more connectors with pre-built self-service data integration in is forcing the complexity onto the user. In reality though, this data is being ingested into multiple data stores. It's coming into cloud storage, it's coming into Hadoop systems, it's coming into NoSQL databases, and it's also coming into staging areas in our classic data warehouse systems. So we're now dealing with multiple data stores to analyze data. Not only that, we're dealing with multiple analytical workloads. For example, analyzing streaming data in motion, complex analysis on huge volumes of structured data, which may not fit in a classic data warehousing system. Unstructured natural language processing, again, not a classic fit. If you shoehorn that into a single column and expected to do it with SQL, not exactly a great way of doing things. Graph analysis, again, more optimized for either a scalable computing environment like GraphX within Spark, or within a graph database, JANICE-DB, for example, maybe even Neo4j, where the API is not SQL to do that. It's a NoSQL data store. And so today, I look at analytics and my customers, and what I see is multiple analytical data stores. Some of them are relational and some of them are not. And we're using them for different kinds of analytical workloads. It's optimized for different kinds of analysis. And we want all of them. It's not replace, you know, it's add to and extend beyond our classic data warehousing environment. But master data is very much in the mix now. But if you look at this from the perspective of somebody like a user, and say, here you are, all of this insight, all of this data coming into all of these data sources, you figure it out. I mean, is that really going to help you deliver value rapidly and reduce the time to value? Are we really going to expect a user to have to access data in multiple different locations, different types of data store, with different APIs, different languages to access them? You know, Hadoop is not a relational system. Yes, we have SQL on Hadoop, but not all data is easily accessible with a SQL interface. Some vendors like MapR with Apache Drill have done an amazing job on extending the power of SQL to work on semi-structured data without a schema. But nevertheless, it's hard. It's hard for a user to access this kind of setup when the spread of data is now sitting across multiple data stores. Well, also, when you look upon this, they have to know about what the data means across multiple data stores. There could be multiple copies of data. Master data exists in the data warehouse as dimensions. It also exists in big data platforms. In my global data lake survey underway right now, the second most popular type of data in a data lake is master data. First is transactional data. But if I go over there, that's not a relational system. That's a file system. If I were to look at social network relationships within an organization, or within customers and their relationships, that data could be in a graph database. Again, a proprietary API to access that kind of data. So it's hard for users to get at this stuff to deliver value. Not only that, but the complexity around data management is huge now. It's no longer just left to right, taking data and putting it in the data warehouse. Now we're moving data in all directions. It could be coming into Hadoop first, it could be coming into a NoSQL database first, maybe moving from there into Hadoop, translated into Parquet format. Could be the case that we're bringing master data into Hadoop. We could be taking data from Hadoop into relational, into our data warehouse to add to what we already know. We could be archiving cold data from data warehouses into Hadoop. So the whole data management scene has become far more complex, and I haven't even looked at cloud here on this chart. So for me, what's been happening is we've been ending up with multiple silos within our organizations. For example, trying to get data into NoSQL data stores and access that has been a different approach from getting data into Hadoop systems. And there's been multiple ways in which to ingest data into Hadoop systems, whether it's with Flume or whether it's with Scoop or whether it's with an ETL tool or the command line or various other ingestion technologies, some of which are out here on the exhibition floor. So just the Hadoop environment is complicated. And then we look at classic data warehouse, where we understand that with ETL and maybe even data warehouse appliances for some machine learning activity that's been going on over there for a number of years. That's pretty well nailed down, but I could guarantee that a lot of the tools being used over here are not the same as the tools being used in Hadoop or even in a graph data store. And so, again, MDM similarly. And so you look at this, and it's siloed. And then you think, well, if that's what we've done so far, is that it? Do we live with this complexity? But to me, there's enormous opportunity. Just look at that green boxes there to rationalize this. We really need to rationalize it. The cost is too high. There's silos, there's skills spread across it. And so there's a number of ways to be able to do this. The first, of course, is to introduce a data management platform across multiple data stores and manage data movement and what data is out there. And of course, introduce the concept of a logical data lake, not a logical data warehouse. A logical data lake consisting of multiple data stores, which, by the way, includes a data warehouse. But that means the data management platform software is having to emerge to be able to define a job once, run it anywhere, or run a job in multiple locations where parts of the job are pushed down to multiple underlying data stores. Also, strategically now important is the introduction of an information catalog to know what's out there across these data stores, to be able to understand what's available so that we can pull value from it and that we can take advantage of. It's not easy for business users with BI tools to figure that out. We need something to help them. But we also need to cover up the complexity of accessing it. And so on top of the logical data lake, we need a logical data warehouse. And that's provided through the introduction of data virtualization software, so that we can hide the complexity of data that's in multiple data stores. And not all data in big data stores like Hadoop is going to be accessible to your average business analyst. Some of the stuff that's produced by data scientists will be available, but you're not going to give them access to all raw data. Data science is very much about producing insights. Data virtualization and logical data warehouse is about consuming those and exploiting them throughout the enterprise to deliver value. So for me, data virtualization is very important, and common metadata between the data management platforms, which are now both IT and business users doing that. Common metadata between these two technologies is extraordinarily productive if you can deliver it. But we also want common definitions up at this data virtualization layer to be able to guarantee consistency there. So what's in this logical data warehouse, this data virtualization layer on top of these data stores? What we now have is a multi-layer virtual tables. We have the data warehouse is a data source. Hadoop system is a data source. We have other additional data that's maybe not in there yet that can become data sources, and we can create virtual tables here. This, by the way, data virtualization software is not new. We're talking 10 years now for most of the main vendors that are in the marketplace, vendors like Denodo, like TIBCO, Red Hat, and whatnot. So very mature software. Also, we can then build an enterprise layer on top of these virtual data sources and create virtual data marts and things like that, and then make it even easier to access so that everyone's coming into much simpler pre-integrated data. And what we're doing here is integrating on the fly. Now, I'll bet you all of you, or several of you, thinking, what about performance? But the answer here is, this is cost-based optimization. We're doing push down to push most of the work down into the underlying systems to make them do the work. And not only that, today I can do all of this in memory and in parallel. So we're able to get performance out of this kind of activity. So if you're going to go to a logical data warehouse, there's several things you need to do. Data virtualization is a key technology, of course. But we also want to modernize existing data warehousing systems. And that means making changes. So for example, moving from physical data marts to virtual data marts. Why not? I mean, that reduces the number of copies of data. It allows you to make changes far more rapidly on the fly. It gets rid of a whole bunch of ETL jobs, gets rid of a whole bunch of data modeling and change management procedures that are taking far too long in order to make changes. So that's one option. Also, you can, as I see far more on the mainland, European mainland than here in the UK, introduce Data Vault as a more modern data modeling technique, which is really optimized for easy change management, minimum impact change management. But if you're going to do that, that's going to create more tables. And so the side effect is it'll create more data marts. So you might get agility on the warehouse and suffer on the data marts. Well, the answer is, if you introduce virtual data marts with a data vault, so you get agility both ends. You get agility at the data warehouse level. I would never use data vault at the data mart level, only at the data warehouse level. But then you get virtual star schemas here. We get agility both sides. And there's a great paper out there by my good friend Rick Van der Lands on doing this. Not only that, but we want to speed up development now. 25 years in, we know how to do data warehouse. And there's a big move, in my opinion, towards data warehouse automation tools. A couple of the vendors out there on the exhibition floor, I noticed. So then also, we're going beyond the data warehouse modernization to extend data virtualization across multiple data stores, some of which are relational, some of which are not. And again, here, what we're looking to do is simplify access, take complexity away from the users so that they can deliver value far more rapidly. In other words, hide complexity. And the way to do that, again, build a layered architecture with data virtualization. So we have trusted, if you like, virtual tables from underlying logical data lake sources. We can build our logical data warehouse on top of that with virtual star schemas, virtual marts for self-service BI, and again, for reporting. And so data virtualization isn't one huge monster model, it's a layered architecture on top of this to simplify access. And again, this layered idea, I'd have to acknowledge Rick for a great paper that he's done in this space as well. But nevertheless, the point being here is you've got a logical data lake. And certainly from my global data lake survey, a data lake is not one Hadoop system. How many of you have got more than one Hadoop system? More than one. Only a few hands. I spoke at the Hadoop Summit. I had over half the audience put their hands up to that question. But so it's not all about Hadoop. It's about multiple data stores and simplifying access to it. And the benefit of this, of course, is if you're trying to get a more deeper understanding of your customers, then we've got the ability to potentially have customer master data. We could have customer relationships. We could have predictive models about customers. We could have customer purchase and transaction history in our data warehouse. We could have customer sentiment and online behavior in our Hadoop systems, and we could be monitoring real-time customer activity in streaming data. So if you're going to do all of that, all of which is customer related, then how are you going to simplify access to give you an integrated 360 view of all of that? And the answer is logical data warehouse. Hide it. Bring it together, make it look like it's a system. We can cache at that level. We can do push-down optimization. We can do in-memory processing at this level. And then we get the ability to bring together a 360 view of data, despite the fact that the insight has been produced in multiple different underlying analytical data stores. Then I can take that data and reanalyze it and cluster it and then break it into much more accurate segmentation. And so exploit that richest set of data, hopefully get far more precise customer segmentation with something like k-means. And then from there, I can do other things, all of that's going to hopefully improve marketing and improve revenue management. So I could potentially do better forecasting out of that in order to help me there. I can move towards dynamic pricing. So using analytics on top of an integrated view of data, not just using analytics in the data warehouse and in the Hadoop system, but then looking at this integrated set of customer data and reanalyzing it, then I'm able to get into prescriptive analytics and start to personalize pricing. And we've already seen some incredible results out of that. Amazon, for example, changing product pricing 9 times in a day, completely automated by this kind of an approach, and push that right into all front office channels. So we're getting demand-driven, dynamic pricing with the ability to cross-sell and upsell across all front office channels using that kind of capability. And so we ultimately, therefore, are able to leverage, on-demand, deeper insight where the hard work has been done down in the platforms, but we then use the logical data warehouse to integrate those components together and then leverage it for maximum advantage, whether it happens to be customer related or it could be operational optimization or it could be risk related. All of those things are all potentially possible. So we've gone from your classic warehouse architecture that we saw at the beginning of this presentation into a more complex analytical setup, but still trying to take complexity away from the user using data virtualization and a logical data warehousing setup. So to wrap up then, I would really say that for me, at least, working in this space now for over 30 years, physical data warehouse is no longer enough. It's just not enough. There's so much more data coming into the enterprise that we now want to analyze. And the impact of that new data and new analytical systems is we haven't got a physical data warehouse, we've got an analytical ecosystem. That ecosystem includes multiple data stores optimized for different kinds of workloads. It includes the need to be able to do data management across multiple data stores. And so you're seeing vendors talking about data management platforms, data fabrics, being able to cover multiple data stores, even in a hybrid world, cloud and on-premise. We've got silos of data and analytics existing within the enterprise, and the cost is too high. And it's hard to access from a business user perspective. You just can't give them all a bunch of connectors and say, you figure it out. I mean, giving somebody access to SAP and say, here you are, 40,000 tables, you figure it out, isn't what I would call productive. I mean, for me, we've got to rationalize here. We need the data management platform and the catalog to tell us how to manage the data stores in the logical data lake. We need to modernize the data, the data warehouse with Data Vault, virtual data marts, and virtual and data warehouse optimization. And we need a logical data warehouse as a common semantic layer, simplifying access to business users who want to exploit it and be able to use it for competitive advantage. So that's really all I have to say. I've been given the time out at the back, so I'd just like to say thank you very much. Have we got any questions? Yes, sir. Can we have a microphone, please? Up here, sorry, over here.
Thank you. Great presentation. I was wondering, you intentionally left out cloud in this discussion.
Yes.
What are your thoughts on the cloud providers and their data orchestrators, like for instance Azure's Data Fabric? How do they fit in?
I think cloud providers. So the question is, what about cloud providers? How do they fit in? I've left it out of here. You could do this on a cloud, just as you could on premise, or in fact the data stores in the analytical ecosystem could be a combination of on-premise, like on-premise data warehouse, cloud-based Hadoop system. There's absolutely nothing to stop that here. The way I see it is a logical data lake could consist of a combination of those, and similarly data virtualization can span both. So I don't see that's an issue. And for me, it's pretty evident the UK is going cloud anyway. So I would, I'm okay with that. All of these technologies, most of them already run in the cloud anyway. So I think the issue with regards to Microsoft's approach here, well, I'll take that one offline if we can, but yeah, I don't see cloud as an issue. Any other questions? Yes, ma'am. Do we have a, oh, here we go.
Thank you. Eridanis, just a quick question on how this will this help also in how we manage the data in terms of customer perspective? I'm on the idea that we are moving towards personalization or collection of data for different individuals, anonymizations,
yep.
opt-in, opt-out.
Yep.
So
yep.
Will this help?
Oh, sure, it'll help, because you're going to have to be able to collect consent even from multiple systems, all GDPR related and all of that. But I think personalization for individual customers is happening. I think it's happening in the sense that we're trying to get the holy grail here is a customer segment size of 1, right? Trying to get to that. But I think on the other side of this, the customer is fighting back. We're all trying to target customer with all of this more accurate marketing campaigns. Customer is now, we're seeing startups emerging where the customer can subscribe to a cloud service, and the cloud service will defend the customer and fight off all of these campaigns and learn more using artificial intelligence about the customer themselves, and then represent the customer, if you like, to give a far more personalized understanding and let in what they think customer wants to see, and block what they don't want to see. So I think. Sorry, I can't hear you with your. Yeah, I honestly I can't hear you at all. I'm sorry. So we'll talk about that offline. But yes, sir. Quickly, we got a. I'm beginning to. I'll have to do it offline. Sorry, we're giving a throat. So for those of you who came along, many thanks indeed for your time. Thank you.